So the next speaker is Mr. Harirajan Padmanabhan, HPAD Inc., OPAF Enterprise Architecture Working Group co-chair. So he'll be speaking on OPAS, your platform for the future. Please welcome him on the stage.
Good afternoon. First, I would like to thank ARC for giving me this opportunity to speak here. So my presentation is called OPAS, your platform for the future, from adaptable architecture to autonomous operations. So over the next 20 minutes, I don't know if I have 20 minutes at this point, we're running over, but over the next 10, 15 minutes, I would like to give you a perspective on how enterprise architecture can help to get the full value from OPAS. Okay, the message is simple. So you got OPAS, which provides an adaptable open architecture. Enterprise architecture provides the traceability and connection. Oh, sorry. Yeah. And so enterprise architecture allows the alignment and AI enables scaling of this alignment. And together, they provide a platform that is for the autonomous operations. So my agenda looks like this. First, I'll talk about the problem we have in modernization and how adaptable architecture can address that, and how the adaptable architecture provides value for the entire ecosystem, and capabilities form a common language for all the stakeholders, and enterprise architecture and AI together make alignment practical and getting into the autonomous operations. So before we talk about OPAS, which you heard a lot from the previous speakers, I'd like to ask two questions. So how many of you expect the current systems that are in operation to be still operating in 10, 15, 20 years? So during that 20 years period, how many of you expect the technology, business priorities, workforce skills, etc., to stay the same without changing? That's not possible. It's all going to change, right? And so therein there lies the modernization problem, right? So industrial automation systems stay in service for a long time, for decades. But during that period, technology changes, people change, business priorities change, and so on. So when we talk about modernization, we often focus on individual problems. We talk about technology, hardware obsolescence, the vendor lock-in, integration changes, difficulty in integrating AI, and things like that. But I don't think these are separate problems. These are symptoms of an underlying problem, which is adaptability. Okay. Technology will always change. The real challenge is to preserve the ability to adapt. So this is why I believe adaptability should be one of the primary goals when we modernize industrial automation systems. How do we build adaptable systems? So when we talk about adaptability, the architecture principles come to mind. Principles like modularity, interoperability, portability, separation of concerns, open ecosystem, and so on. So OPAS was created with these principles in mind, but these principles are not the objective. Adaptability is really the objective of OPAS, at least how I think about it. So on the left, you see various challenges, obsolescence, vendor lock-in, integration complexities, skills constraints, AI adoption barriers, extensibility, and so on. These come in the way of adaptability. The principles that are applied here in OPAS address these barriers to adaptability to achieve these outcomes. So who does adaptability benefit? End users, yes, but it's not just end users. The OPAS ecosystem consists of various stakeholders, end users, and suppliers, solution providers, system integrators, service providers. So each stakeholder contributes something different, and each creates value in different way. For the end users, it's about lower lifecycle cost, technology flexibility. For suppliers, the adaptability allows them to address larger market, a faster product adoption. Solution providers provide differentiated industry solutions through adaptable architecture, and system integrators provide reusable architectures and so on, and service providers provide repeatable offerings, outcome-based service, etc. The important point is architecture is shared and the value is stakeholder specific. So that's what makes OPAS more than a technology architecture. OPAS is an ecosystem architecture. So if so many different organizations contribute to the final solution, how do we keep everyone moving in the same direction? So end users define business objectives, and suppliers provide products, solution providers provide industry solutions, etc., and system integrators and service providers have different contributions. So they're all making different contributions, and but it's not about, the challenge is not in creating good products or good solutions. It's about making sure that they all support the same business outcomes. So an excellent product doesn't necessarily create an excellent solution. An excellent solution doesn't automatically deliver excellent business outcomes. Alignment is what connects them. And as more organizations become involved, alignment becomes even more important. So the next question is, what allows all these stakeholders to speak the same language? So different stakeholders naturally think about different things, right? An end user thinks about business outcomes. A supplier thinks about products. System integrator thinks about solution architecture. A service provider thinks about transformation. They're all looking at the same problem, but from different perspectives. That makes alignment difficult. This is where capabilities become important. Capabilities provide a common language for all these stakeholders. And instead of asking the question, what product should I buy? Which architecture should I implement? The question becomes, what capabilities do we need? And once they agree on the capabilities, everything else becomes a lot simpler to address. This is why enterprise architecture has used capability-based planning for many years. It gives everyone a common reference point before discussing specific technologies. But agreeing on capabilities is only the beginning. The next challenge is maintaining that alignment as everything continues to change. So this is where enterprise architecture becomes important. Not because enterprise architecture produces a lot of documentation. It's but it helps to preserve the understanding of as the evolution as enterprise evolves. So think about what happens during the years of service with the business, right? Business priorities change, capabilities evolve, solutions are upgraded, and architecture changes, and so on. And without a way to connect these changes, alignment is gradually lost. So the graphic shows 4 connected views of the enterprise. You've got architecture, solutions, capabilities, and outcomes. Each layer influences the other. And what is important is the relationship among them. So if we can trace business outcomes, we can trace the business outcomes to specific capabilities that enable the business outcomes. The capabilities are delivered by solutions, specific solutions, and the solutions are enabled by specific architectures. These connections are important to preserve alignment. And this is becoming becoming more important than ever with increasing complexity and the pace of change of everything. But how do we maintain these connections? It has not been possible to maintain these connections so far in the past decades. But now we have AI. So AI is got a role to play here, which AI actually changes the picture. It's not because it replaces the engineers, but not because it replaces architects, and it's certainly not for making decisions for us. AI helps manage complexity. Organizations already have enormous amounts of knowledge, standards, requirements, designs, operational knowledge, etc. AI is able to discover elements from this knowledge and connect them up, and through their relationships, and maintain that traceability even as things change. So you end up with a continuously evolving enterprise model which can help with making decisions. So the model consists of everything about the enterprise, the business outcomes, the capabilities, the solutions, the architecture, and so on. So it's a representation, it's a model of the entire enterprise. So my message is that OPAS provides the architectural foundation, enterprise architecture provides the method, and AI makes it scalable at the industrial scale. Now, let's see how this platform enables the autonomous operations. we saw, I talked about how AI can help in maintaining the traceability and modeling the entire enterprise. But AI can also become part of the operation itself. So, which we heard a lot about AI applications, AI being used in industrial automation in the last 2 days. And there, the problem is common among many industries. The aging workforce, increasing operational complexity, higher expectation for safety, reliability, and performance, and growing interest in AI-assisted autonomous operations, right? The question is whether AI will become part of industrial automation. And it is already, as we saw it in the last 2 days. But the real question is, what kind of architecture allows those capabilities to keep evolving over the next 20 years? I would like to talk about a case study in this case. Texas A&M implemented an initiative, a control system for a small medium reactor. And they built it on the COPA platform, which implements OPAS. And their objective was not just to add AI, but the objective was to move towards autonomous operation. The system continuously monitors the plant data, and it uses AI to detect anomalies, and it invokes automatically diagnostics that are needed and predicts the system in how the system is likely to evolve, and assist operators with recommended actions. The important thing is in this implementation, AI runs locally on the COPA platform and keeping the operational data secure. And their objective was to get greater operational flexibility, reduced staffing requirements, and support for remote operation. The fact that it was a nuclear application isn't really what is necessarily interesting about this. It is, we could, such AI-enabled functions or capabilities are going to be added, and are being added in other industries, other chemical plants and manufacturing facilities and other industrial operations. The key thing is the underlying architecture must be able to evolve as these AI-enabled capabilities are added. So OPAS provides an architectural foundation designed for long-term adaptability. Enterprise architecture helps maintain alignment as new capabilities are introduced. And AI becomes another capability that can be integrated, governed, and continuously improved over time. This is the real significance of this work. It's not simply about using AI. It's about demonstrating how an adaptable OPAS-based architecture can continue absorbing new AI capabilities as they emerge. That's exactly the direction I believe industrial automation is heading. So autonomous operations don't begin with AI, they begin with adaptable architecture. So let me finish this presentation by calling out the key takeaways. So we have the modernization challenge, which is addressed by adaptability, adaptable architecture. OPAS provides that adaptable architecture. Enterprise architecture provides the alignment as things change. AI makes that alignment scalable, and together they provide the platform for autonomous operation. I think that is my last slide. Thank you very much.